This is the beginning of chapter 12, which is about solutions. Solutions are extremely important because most reactions occur in a solution. And as you're going to see, that partly is because of our broad definition of a solution. But before we get to that, there are two parts of a solution. There's solute and solvent. You can have more than one solute, but you typically only have one solvent. And so the solute is the solid or gas dissolved in liquid, but the generic or the broader definition is it's the component in a smaller amount. The solvent is the component in the larger amount. It's typically the liquid that a solid or gas is dissolved in. So this picture here, this is copper 2 sulfate because it's characteristically blue. It's a solute, and I add it to water and I make a solution, which a solution by definition is a uniform mixture or homogeneous mixture. There are types of fluids. There's miscible fluids, and that's shown here. Okay, this is acetone and water, and this molecule here is water, and this is acetone. And miscibles is the fact that they're all mutually dissolved and they're together, versus an immiscible fluid is fluids that don't mix but form multiple layers. And so this is an example of that. Here's the methylene chloride is on the bottom here, okay, and you see the fact that there's none of these green balls with blue sides on this up here at the top. And this is water here. That's the oxygen, hydrogens, and there's no water molecules down here, so it forms two very distinct layers, and you visually can see that. Okay, so if you ever have seen gasoline and water's on the bottom and gasoline's on top. That's another one, but you can distinctly see that level between the two. So this is a solution, and this is not. Okay, because a solution is homogeneous mixture of the two components. Now, we classify solutions by the phase of the solvent. Okay, so I can have a gas solution, which is just simply a mixture of gases. I can have a liquid solution, in which which is what most people would think about as being solutions, and I can dissolve a solid, a liquid, or a gas into that. Okay, so we saw in the previous slide here, this is a solid going into a liquid, so that's a solid. This is still a liquid solution. This is an example of two liquids mixed together. Acetone is also a liquid, so this is a liquid-liquid solution. And a gas into a liquid would be something like soda water, like the Diet Cokes you see me drinking a lot in class. Okay. A solid solution is just a mixture of solids. Typically it's metals like brass, but it can, and again, it has to be homogeneous. Okay, so saying that you have sand and rocks, that's a heterogeneous mixture, so therefore it's not a solution. So there has to be a solution, means that you can't tell what the parts are. Okay, this one hasn't dissolved yet, but you still see the solid going into the liquid. So this is actually still a heterogeneous mixture until whatever that substance is completely dissolves in there. Okay, so these are some examples. This is out of the textbook, table 12.1. Solution is air. It's a gaseous solution, and so it's oxygen, nitrogen, carbon dioxide, and others. Okay, if I have soda water, that's a liquid, and it's carbon dioxide dissolved in liquid water. Ethanol, which is the alcohol that we drink in water, is two liquids. So think about a rum and Coke. Okay, a brine, which is something, it's basically just a very salty water solution. The ocean's sometimes described as being briny. You also, if you cook Thanksgiving dinner, they'll talk about brining your turkey, which means basically soaking it in a salt solution. So it's another liquid solution, and it's solid sodium chloride and water. I can have potassium sodium alloy, which is still liquid. Okay. Dental fluid, dental filling, the alloy, amalgam, is mercury. It's a solid one, plus silver and other metals. Your jewelry that you wear is typically a solid solution. It's this is talking about silver and gold, but you can also have gold, and chromium is typically your yellow jewelry. And so that is the end of section 12.1.